for joining us tonight. We are going to be having a discussion about a revolution in software. We're going to be talking about software containers tonight. So if anybody showed up and didn't want to talk about software containers, you're out of luck. But who knows? You can stay. Who knows? Maybe you learned something you didn't know. So we have a panel with us tonight, which makes every discussion even better. So probably the best way to start things off tonight is to have our panel members introduce themselves, perhaps give a little bit of background, and let us know where they are currently. So George, could we start with you, sir, perhaps?
Sure. So my name is George Willis. I'm the Executive Director of Container Hosting Services at DTCC. Before that, I spent 7.5 years at Duke Energy, where I met a lot of electrical engineers who outed me to come and speak with you today.
Excellent. Fantastic and wonderful. Next we have Jason.
So Jason Olmsted, I work at Nielsen. My official title is Principal Software Engineer, CICD Lead for Engineering.
Okay.
I also am in the process of co-creating a platform team within engineering that essentially will be introducing Kubernetes in a standardized way across the organization. And I'm also co-founder of the Tampa Bay Kubernetes meetup.
Excellent. Very good. And where were you before you were at Nielsen?
I actually worked as sort of a web commerce web engineer for a printing company, Dartmouth Springs.
Okay.
So it was pretty much all web, all digital sales.
And you've been at Nielsen for how long?
Going on 8 years.
Whoa, that's almost a career. That's like going to high school twice. Well, very good. Also on our panel tonight, we have Jess.
Hey, I'm Jess Bodzo. I'm a software engineer. I also work at Nielsen. I actually used to work with this guy, and by complete happenstance, we ended up at the same panel, which is kind of funny. I use containers day in and day out a lot, so this is right up my alley. And I'm here because a very good friend of mine knows you guys through IEEE USF.
Excellent. It's a small world after all. Fabulous. All right. Well, very good. So we have a fantastic and wonderful, very distinguished panel. Once again, gentlemen, thank you so much for agreeing to participate in tonight's discussion. They have all of the knowledge. And for everybody in the audience tonight, I told them they should expect that the audience would show up being seasoned professional container experts who were really just looking for a little extra something around the edges because they already had it down cold. Okay, I actually didn't say that. I said assume the audience doesn't know anything about containers, and let's take it from there, okay? Because I was really speaking sort of for myself. Okay? All right. I have a couple of slides that I prepared, and all I'm trying to do with my slides is just sort of get the discussion going, okay? So there's nothing really major here, and dear God in heaven, there's not a lot of slides. So let's take a look and see if I got this going on. Well, apparently if I'm not going to advance, we will actually not be taking a look at any slides.
Yeah.
Something to know. Well, the computer locks like that, just it's interesting because we're here to talk about software, and we're here to talk about some challenges that we have with software. But you know, what we're going to be talking about tonight actually has a real physical analogy, I guess would be the right word to say it. But the folks who do shipping of real physical products have had this problem for like years and years. And if you think about all the things that we can buy from Amazon, because I get my 85-inch television from Amazon, and I can also get potentially my diamond ring from Amazon, right? You know, so different sizes, different shapes, different quantities and stuff like that. And it all comes from China anyway, so whatever. Somehow it has to get from China to my house, right? And it posed a huge problem for the shipping industry because they had different things and they were in different boxes. And when you put all those different boxes together, you got to put what the small box was on top and the big box was on bottom, and it was just turning into a huge mess. Interestingly enough, and a little hats off to the U.S. government, the people who originally solved this problem was the U.S. Army. So the U.S. Army sort of stepped in and said, we're shipping a lot of stuff. And so they standardized what shipping containers looked like. It was like, oh wow, that's pretty good stuff. Time goes on, and that was really just being used by the military. I think the commercial world was still a bit of a mess. There's a company, and we all know who they are. They're Sea-Land. We've seen Sea-Land, probably trucks on the road, right? Sea-Land trucks and stuff like that. Well, apparently it's this massive shipping company. And so they hired one guy, and that guy was really smart. And he must have known something about the military because he said, hey, Sea-Land is going to standardize our shipping containers. And so they did. And when Sea-Land, which was a massive company, standardized, apparently the rest of the industry said, wow, great idea. And that's why we can see those pictures of all those ships that have standardized containers on them stacked really way too high, in all honesty. But they can ship them around. They can put anything they want into those, and they don't care, and they have the ability to arrange them and stack them, and they're fat up and happy. So the guys who do actual physical shipping realized a long time ago that if they put everything into a standardized container, it made their life a lot better. It's like, wow, that's great. And then we come to the world of software. I don't think we ever really quite wrapped our head around that. So we continue to develop software, and it looks different every time we do it, right? It's one component or two components, or I use this library or those libraries, or I build it on this operating system or that operating system. It's different each and every single time I do it. So containers are a solution to a problem, okay? And I made this problem up, and I'm very proud of myself for actually making the problem up. So potentially, if I'm a software developer, I'm working on my desktop, and in order to build the fantastic, wonderful TikTok, I decided I'm making the TikTok app. Does anybody know about TikTok? I see a lot of gray hair here, so you should know about it. The TikTok application, which actually really does exist, allows you to make 15 seconds, it's really short, really 15-second lip sync videos to your favorite songs. Apparently it's all the rage. It was all the rage in the US and then got bought by a Chinese company. Apparently, I guess it must be all the rage in China, so go figure. But anyway, I'm working on a TikTok application. I'm doing a great job. To do it, I use a series of packages. So I'm not writing the whole dang thing, right? I'm using a bunch of stuff. I use the Python programming language, important here, version 2.7. It's the old version, whatever, I'm using it. Django 1.11, a bunch of icons that I use. MongoDB, which is a database, I'm using version 2.2, and Node.js, I'm not quite sure I'm using, but whatever, version 10.5.1. I have this all on my PC. I write this beautiful code, it works perfectly. My boss is going to love it when I show it to him. My business has a test environment. So I take my beautiful code and move it over there. There's a problem though. The problem is in the test environment, they're using Node.js version 8. Is my code going to work? It might, right? Sometimes we get lucky, right? Maybe I didn't use any of the fancy new stuff, so it's going to slide in the, thank God, okay. And then Friday night comes, and on Friday night we release software from the test environment into the production environment. The problem is in the production environment, there's 4 different things that are different about the production environment than on my desktop. What's going to happen to my code? It's going to bite the big one, right? That code ain't running. It's funny because my wife works for Moffitt Cancer Center. She's a hardcore coder. And she likes to say, if cancer doesn't kill you, the paperwork associated with having cancer certainly will, right? Because she automates paperwork for it and stuff like that. This kind of stuff happens all the time for them, right? They'll move stuff into production and it won't work because something glitched. They don't have the latest Java libraries. They don't have the latest this and stuff like that. So this is a very, very common, and actually today, in the way we do software, considering we use so many libraries and so many other sorts of things like that, it's happening more and more, okay? So this is a problem that we're all faced with today. So, this is the problem that containers are designed to solve. And this is just a real good, quick touch to show you what a container sort of is. So, the computer that you're using has a host operating system, and that host operating system can be Windows, it can be Mac, it can be Linux, it can be anything you want. You have a container runtime, which is a piece of software, and then on top of that, you build your applications. They all run on the sort of container runtime, and then you put your special stuff on top, and each one of those is considered to be basically a container. Cool. So I'm just going to leave that. So now we have just a little touch, okay? Just a little touch of what it does. We know what the problem that containers are designed to resolve. When we put together software today, we use a whole bunch of different components. We use compilers, we use libraries, we use stuff. And when I put together one computer and move it to another computer, it might have different stuff. If it has different stuff, the software's not going to work. So that's a fundamental problem. And that's what containers are designed to solve, among other things. So, the question is why would I want to go through the hassle of using this new container stuff? Hey, George, throw that one in. That incredibly generic question in your lap, and just sort of see if you want to run with it. Why would I want to use containers? I've lived my life to this point without containers. Why now containers, sir?
Well, containers are much more efficient than using like virtual machines. So, I get asked a lot what are containers and things, and I usually tell people, just take everything you know about virtual machines, pretty much, it's very transferable knowledge.
Yeah, I'm going to stop you right there for 2 seconds. Because you said the magic words virtual machines. Quick question, sort of show of hands. In the audience, do you guys know what virtual machines are? Everybody good with virtual machines? I'm gonna see. Let me see the. Your hand did not go up. Is that correct? A half up.
So Java, but it's kind of like a virtual machine.
Yeah, you know you're exactly correct. So just real quickly, a virtual machine effectively is I have a physical computer. And the physical computer has obviously a CPU, it has a hard drive, and it has maybe some networking gear and stuff like that. And a virtual machine means I get to create basically a computer in software that runs on my computer. So I'm just making a whole computer, which means I can also make another computer and another computer. So I can make multiple virtual machines. And in each one of those virtual machines, I can load a different operating system. So on one physical machine, I could run Windows, I could run Linux flavor 1, Linux flavor 2, and then I could load up all my software on top of it, right? So one physical computer, I can run effectively 3, 4, 5 virtual computers on just one computer. And people went ape over this in data centers because they'd been on one physical server and they'd been running their HR system on another physical server. It was really inefficient because they were only using like 10% capacity in both of those. But hey, with the virtual machine, I could take my HR system and my email system and put them on one physical server, but they all look like they're running on their own special computer, and then everybody's happy. So that's the world of virtual machines. Does that make sense? Yeah. Cool. And now we're back to you, George. So we're talking about containers, right? And you're saying the containers, just, we throw all our virtual machines away. It's a horrible, terrible, we don't need them anymore.
Well, I won't say that. I'll say that there's two compelling things about containers to me. One is the bundling capability, and the other one is what we call density. So, and so I'll start with density. And as you spoke of, really started out in computing, where we had hosts, and we would put critical applications on hosts, and then the computers, our servers grew in size. They got multi-core, and they started to grow. So we smartly started putting more applications on those same computers. Only if application number 1 went down, it was dragging the entire box down. So now if you had 4 applications on a host, and one went rogue, you lost 3 mission critical applications. So this wasn't working, right? So we entered the realm, we needed, the next step was single tenancy, right? So what we started to do is say, all right, separate them out. Put one critical app on each one of the hosts, right? And we were running hosts that way at like 10 or 20% utilization. Silicon Valley was burning a power bill, and you know, it was bad times. And then virtual machine technology came along. And virtual machine technology offered a way to solve both problems. You could stick several, what were previously machines, you could image those and stick those on one machine. Instead of having each machine run at 10%, you could take 8 of those machines, stick them on one box, and have it running at 80%. And if one of those virtual machines went down, it was guaranteed not to take down the other virtual machines. So you had multi-tenancy, right? They could all exist in an apartment building, and if one had a fire in their apartment, it would burn down the rest of the apartments. Okay? Now containers go beyond that. And containers increase the number of apartments you can get into a building. And it does that through different use of resources. It's much more efficient on how it uses resources. Virtual machines, they're pre-allocated. So if you take 16 cores and you take each 4 virtual machines and you give them each 4 cores, that's what you get. If they use 2 cores, instead of all 4 tough, they're wasted 2 cores. They are pre-allocated out on memory, they're pre-allocated out on CPU, right? It's like taking a closet, putting a pallet rack in it, or storage, and putting a pallet rack in it. You're separating the spaces out, and the actual shelving itself is kind of sizable, right? Because you're running through a hypervisor on virtual machines, so you're losing some storage space running that extra layer, right? Containers are more like shrink wrap. So they go right around the contents in a way, and they use quotas. So if you ask for 4 cores and you use 2, those other 2 cores are still available. They're still available out there for other people to use. Same with RAM. So you just do maximum quotas and it won't go beyond that. But if it doesn't use up to that, that's still available in the pool. And so you can get much more processing on the same box, right? So that's the density aspects, right?
And that's good. So my wife and I have been watching this Netflix show about this very, very small Japanese lady who shows up at people's houses and helps them organize their disaster. And it's not quite hoarding, but it's close to hoarding. And her secret is she shows up with boxes. And you're supposed to fold everything and put it into boxes, which is almost sort of like,
Exactly.
she's almost like a container spokesperson. I guess, I don't know if she knows that, but potentially. Excellent.
Thanks, it is now.
Please, go ahead.
I have a question for you, George. Your second entrance into this discussion. So you would say that container is something like a tool that aids in the design, development, and integration of software processes in general.
In general, containers are a way to contain processes. So typically, what we did before is we took an entire host with all of its processes, and we stuck that, encapsulated that, that's the key software term, encapsulated it, and we called that a virtual machine, entire machine. Now we're taking much smaller amounts of processes, right down to a single process, and we put that inside of its own encapsulation. We call that a container. So it's really process or we talk about data processing, right? There's two parts of that, the data and the processing. This part, containers, plays in the processing space, right? To make processing portable, I can move containers around, I can send code around, run times around, and I can spin them up in under 4 seconds, put them into play on distributed servers.
And actually, I think that George just tapped on something very important there. So virtual machines are the greatest things since sliced bread, or they were prior to containers and stuff like that. And people were very excited about virtual machines because you can start up a virtual machine much quicker than you can actually configure a physical box, right? Physical box, you have to rack it, you have to wire it, you have to do some. The virtual machine is just software, so you're really saying I'm going to get going. But a virtual machine still takes a while to spin up, to use the parallels. But I believe in the world of containers, it cuts like the time that it takes to boot it up way down, right? So virtual machines better than physical machines, no question about that whatsoever. Containers better than virtual machines as far as getting stuff up and running and doing it really quickly. Is that a correct statement?
Yeah, and then I want to pass the token here, but when you're booting up a VM, you're booting up a lot of processes. You're bringing up an operating system from the ground up. How many processes are you bringing up? When you bring up a container, you start with one process. It may spawn a few more, but it's a very small footprint. So yes, it's much faster to deploy and spin up.
And to take his analogy to further, so the apartment model, containers, true, and I love them, I don't know why you put me push the thing, but the walls are much thinner. And so from a security model point of view, you don't have the level of encapsulation. And that's why you find people trying to weigh containers into a virtual model, a virtual machine model. Particularly security professionals are saying, we figured out how to do the security in virtual machines. A lot of times a container can run as a root or privileged control. Once you have a container running as privileged, it can go snooping around. You can do anything. You've essentially handed anybody that can access that container root to the host.
Okay.
So realize that it's a great model, but it does come with extra challenges, and we don't want to forget those. The other thing in the virtual machine is also realize you're right in so much as you can allocate that, but because it is such a hard limit, one of the reasons containers are better, people started over allocating the virtual machines. I don't need the capacity all the time. I've got maybe 16 real cores, but I may allocate like 32 cores worth of virtual machines there on the hope and prayer that they don't inflate at the same time. So
I feel lucky.
So containers help us with that better utilization without us relying on ourselves and pray.
Okay, so we have Jason talking, so this is good. So now we're going to hook him on. This is really clever how we do it. So Jason, fabulous. So I'm working at the company. We don't use containers. Well, my CIO, of course, has been reading the latest trade rags that say containers, containers, containers. And so he comes to you and he says, Jason, we're going containers. So, oh my God, what does that actually mean? So how does a company go from no containers to containers? What are they going to have to do? They're going to have to shift their thinking probably, right?
Absolutely.
Okay.
But it's going to depend where they start, right? So if you're living in the Java world and you're running through a Java container like Tomcat or JBoss or Elasticsearch, then you're already potentially multi-tenancy, and you're probably already highly motivated to deal with it. You're already dealing with grief. No matter what, though, before you get the containers, you probably got swept up in the microservices as a buzzword. And Mark Fowler, who's a very, very smart guy from ThoughtWorks, did an article. You must be discalled in microservices. One of the things that happens is that you start breaking these containers. There's such a great coherent place to do this encapsulated work, and I don't want multi-tenancy. I want a single use. So I get a process here, and a process here, and a process here. And suddenly, even though everything loads much better, I have so much more to load. And if you go back to your picture, just mentally at least, you realize you go from a single ship, and you've got a few stevedores, and they're loading stuff in, and suddenly I've got this huge dock, and I've got lots and lots of containers. I got to keep track of what's what and make sure they go to the right ship at the right time. And so, yeah, we're going to have to sit down with the architects and figure out what does it actually mean. Now, I was talking ahead of time. I don't know if you coined the phrase. There's got to be a better one out there. But we talk about going to cloud, being lift and shift. I think going to containers can be shove and push. Okay. I'm just going to force myself in this container because there's virtue in orchestrating it that way. And then I can learn what are the tools that lets me do that. Probably later in the conversation, we'll graduate to what those tools are.
You bring up an interesting point. So let me just run something out in front of you. So my company's already developing obviously some software. Great. You know, if we decide, hey, we're going containers, could we just take the software that we're developing and just shove it into a container and say, yay, we're using containers? Is that acceptable to do?
You can do it in certain cases, and better than going to the cloud, it actually does solve a lot of problems all by itself. In fact, I was in a training recently, and the instructor had this really great idea. He asked this question of, if you're using scripts to do deployment, and the artifacts you're trying to deploy, even under the traditional model, forget the fact you might use Kubernetes, where version control do you put this? Are the deployment scripts next to the artifacts? Are they somewhere else? Are you spread out? And the suggestion he had, which seems obvious in retrospect, was you can actually create a transient container. You can store it forever, but that contains your artifacts that need to be deployed, or at least references to them, and your deployment scripts. You just actually have one container. And now I've encapsulated a deployment state in a way that's version controllable, and that's contained. It's not scattered through different scenarios. And I'm not mixing my, don't want to go too far. I don't necessarily want to mix my artifact version control with my code version control. Right. So, yeah, I think there's some transient, even if you don't re-architect, even if you don't do the coolest architectural trends, I think there are inherent advantages to managing with containers. That once you free up from an automation point of view, you can actually start to go through, I won't say refactor because they're controlled at similar to a test, but you can start modifying your architecture to take more and more advantage of it.
Gotcha. All right, so day one, I can sort of shove stuff in a container. And, you know, check off use containers when I CIO sends by my desk. Hey, we're using it. And then over time, figure out the best way to architect. Right.
And you'll have pitfalls doing that for sure, right? Because your containers will be huge. You may have other things that are
My
happening.
container's this big.
Right. So, but I think it's reasonable to do that and empirically see, is my solution still working, and did I save time? I think I mentioned stevedore. I mean, I'm doing manual deployments or even automated deployments for things like Chef or Puppet and Resolve. Am I going to get a benefit on top of using those for predictability? It's the same container every time. I mean, it addressed the issue you had before. So at the very least, I'm getting consistency, even if I'm not being efficient or effective.
Oh, wait, oh my God, the questions are flying out, please.
Hey, listen,
Herman,
you
you
guys,
already went, so we'll go with Jim first, and then we'll swing back to you.
fantastic, anytime.
You brought up another concept, and that of microservices. That old news, or these two concepts of containers and microservices orthogonal? Are they running together?
Definitely, you'll be able to answer as well, but you can do microservices without containers. There's this concept called serverless, which we'll pull to the side. You can do it even traditional deployments as well. But the problem is if you don't have something that you can orchestrate automatically, the number of individual things you have to deploy and potentially keep synchronized, and the other cognitive loads associated with it, they pretty much are like peanut butter and chocolate. They go together so well. But asterisk, you don't have to do them together, because that's kind of where the flow takes them.
So, and perhaps the challenge, so, you know, just the phrase, microservices, right? So that smells like a little bit of code, right? Which is effectively what a microservice is, which is great, and it has some real advantages to it. The problem is if you have a lot of code and you turn it into microservices, that means you have a lot of microservices, right? And so your management issue of a whole bunch of small pieces of code starts to get crazy-like. Does that make sense? And so
It makes sense.
If you have containers that you can shove those little pieces of code into, all of a sudden you don't have to deal with all the little pieces of code. You're just dealing with some containers that contain a truckload of code, right?
But this question comes from someone from outside the computer science world. In my perception of at least some of the microservices implementations are those microservices that are implemented across different computers that would be outside of the container, and that you would go to those microservices to pull in Now, is that an erroneous assumption or
I'll give you a quick
perception?
definition of what I think microservice is, and I'm sure my partners want to talk. So a microservice is a coherent bit of code that brings its own data with it that can deploy independently from its peers. And so how you accomplish that is up on you. And I take it that there's another thing called a service-based architecture where you might use shared databases. So I've done service-based architecture not using containers, using traditional JBoss and Node.js applications. The reality of that scenario though is we increased the number of artifacts that need to be deployed. They had, even though we did good things to abstract, they still had bindings of the data, and therefore they had synchronization at the point that had to occur. And so it became very, very painful, and it became error prone. So I don't think there's a purest way to say that you can only do Microsoft or microservices using a container. You could also use serverless, which is way better yet, and actually where containers are heading. But again, in purist, you don't have to. In practice, you're going to want to.
Cool. All right. Herman, did you have a question, sir?
Yes, Jason, since you are there so thoughtfully listening to us, I have a question for you. What are the requirements for containerization of the software? How do you containerize a piece of software? Are there specific requirements associated with that?
So basically, there's this concept called infrastructure as code, and pretty much everything is as code. So a container definition is a text file, a YAML file, and you give it a base. I'm going to choose either nothing or another container upon which to build my definition. So if your solution, you can't think of a solution that could be containerized, in an edge case, you will define in code how your container is assembled. And I think what ends up happening is you can put any solution into it you want to that's code. You can do it in very gross ways or clever ways. Where it gets interesting though is there are patterns. One group of patterns is called the 12-factor application, and how you expected the application inside a container, inside any cloud native scenario to behave. That's where it gets interesting. It's not that the container intrinsically demands you do certain things. It's just that once you have a number of these things going on, if you have a microservice, you do want coherency, right? I want it to do one thing and want it to do well. But I got log files. I want to know what's going inside of it. One of the other great things about containers, imagine you've got your container. You want to lock that guy. He goes on the boat. You're not opening it on the ship, right? In fact, technically speaking, in software, you never want to open it again. Because from a security point of view, if it's immutable, you get lots of huge benefits, right? From a predictability point of view, if it's immutable, you know it's there. But you want to know its state. I mean, it's generating things. So writing things like standard out and standard error is a general pattern that's evolved so that you can look inside of it. There may be tooling you would do with application performance monitoring tools like AppDynamics or Asana or open source Prometheus that'll help pull that information out. But now I've got extra stuff I've got to bring up alongside to keep track of what's going on. There's entire stacks of technology that are designed to assist that information, visualize it, potentially apply logic to it, so I can predict what's going to happen or know what happened inside of it. So the easy answer is you can quickly port, but to be successful long term and to keep keep your wits and sanity about you, you're going to have to start modifying the application to be more consistent with this type of deployment strategy.
Okay.
Does that answer your question?
Yes, yeah.
Good for now. Good for now. Okay,
Good
so
for
we'll do
now.
more questions coming, but we'll deal with that further right now. Well, excellent. So somehow in our discussion of containers, we've made it to this point, Jess, but we've not mentioned Docker. How is that even possible? My question to you. So I've heard about this. I've heard about this thing called Docker. I've heard about it in the same breath as containers, but I have no freaking clue what it is. Could you tell me, sir? What the hell is Docker?
You can certainly try. It's a company with an awesome logo. That's the whale with all the shipping crates on its back. But basically, what Docker kind of innovated on in the early days was making a clean layer of abstraction between the operating system that runs your code and the actual app inside of your container, because it can get really untenable and difficult to deal with all these differences between different types of underlying operating system architectures, and you need to make assumptions about what it means to write to a disk or to talk to the kernel, and it leverages a lot of features that are built into the Linux operating system kernel to do that in a pretty consistent way. And so I would say the biggest contribution that Docker has made is making a standardized way for the industry to take advantage of these features in the Linux kernel that allow them to use these containers. Because a lot of people just frankly didn't have the domain knowledge to deal with all of the ins and outs and complexity of running these container workloads before Docker came along. And it's worth mentioning that I think they're kind of sunsetting now, and that's my personal opinion, but there's some evidence in the community that people want an open standard that a private company doesn't have a say in, that everybody can use and everybody can evolve together. And so you'll see competing standards to Docker that provide similar abstractions, like there's one called Rocket, RKT, that's pretty popular, or there's a thing called the Open Container Initiative, and it's designed to replace this proprietary company's implementation of this virtualization, this container isolation of the operating system.
Gotcha, okay, and actually that is sort of the key point as to where it's going and stuff like that. All right, well that's cool stuff there. So it's interesting, you bring up a really interesting point. So the concept, or I guess basically underlying tools that allow you to do stuff with containers, it was part of Linux before Docker came along.
Right.
And the Docker guys were just smart enough to go, oh hey, there's some cool stuff there, and then they built some tools that made it easier to use. Basically, I mean, shit, why didn't I think of this? Damn it. another Facebook idea that got away from me.
Well,
You know-
Google developed the control groups.
Right.
Google has been playing around. There's a hit using virtual machines, right? The hit using virtual machines, you have to go through a hypervisor.
Right.
Everything has to go through the hypervisor, and there's a performance penalty for that. They have that piece of management software to create a multi-tenancy model for virtual machines, and Google didn't like that. So Google started to say, rather than load the operating system into each virtual machine, and I've created virtual machines that were 95% operating system, because all I wanted was an RDP application, right, in a virtual machine. And it was just bloated with operating system. And so they were having the same problem. So it's like, can we share most of the operating system was the goal. And that's what containers do. They share the kernel of the operating system. And then each container is just processes that are running on that kernel. So it's a very similar model to kind of a bare metal hosting model where you have an operating system, you have processes that run on it. But it turns your processes into narcissists, right? If you go inside a process and do a PS and say, what do you know about it? If you go inside a container and do a PS, what processes do you know about? It knows only about itself, right? It's truly encapsulated in its own little world. That's all it knows about. And the only way it can talk through the boundaries of the container is to specify ingresses and egresses, ports, IP ports, just like we've always done. So it's the same kind of host-to-host model, only we use the container.
Okay. Hey, so, and George, I'm going to stick with you for just a moment here, sir. So we talked a little bit about virtual machines and stuff like that. All this container stuff sounds a lot like virtualization. What's the difference between the two? Something like running multiple applications on the same server, isn't it sort of the same damn thing? I mean, different start to the C as opposed to a V, but outside that.
Well, but it's a good
I
question.
spent a lot of time studying my damn VMware, and do I now like out to field, out to pasture, or what up?
Well, VMware has licenses associated with it, first off, to run those virtual machines. But you're not wrong. This is just the most recent flavor of virtualization. It really is. And like I said, a lot of the knowledge you have on VMs is very transferable. It's just a lot denser. You can get a lot more containers on a host than you can get virtual machines on a host. And really applications and services are what you're trying to get on a host. You make much more efficient use of that. You get a great deal of portability out of containers. You don't get with virtual machines because I can say deploy a container over there on that server and spin it up very quickly. I get resiliency aspects out of containers I don't get with VMs because they have concepts of replication sets and health checks to make sure the containers are started that I can say, based on the current I/O limits I have, please add another container. Then we create replica sets, and you might start with 3 into replica sets. It's just 3 clones of the same container running. And as workload comes in, it'll spawn a 4th. And if one gets knocked down, it'll detect it and replace it. And so you get a lot of resiliency built into that model. So we were talking earlier about reactive manifesto and having built systems. capability, especially in stateless containers, of just having as many of those as you want, spin up and spin down, and to be moved around. I can take it from one data center if it goes down and deploy them over to another data center. It's a huge game changer in resilience.
Please go ahead.
So I'm not familiar with Docker. So is it a company, a private company that sells a software product?
Yeah, so let me back up on that a little. So Google was doing these C group things, right? Control groups and building capability into the Linux operating system so that containers could exist.
And they released that code for everything.
That code was part of the Linux kernel, right? And so I could spawn processes that wouldn't know about other processes. And the company that became Docker was actually a hosting company. And what they cared about is, we're selling hardware. We're selling we're like Amazon, we're selling virtualized hardware. So I need to get your applications online as quickly as possible with as little human intervention as possible. And I need to make the most use of my metal because I have capital expenditures for servers and disks and that kind of stuff. Right. So how could I do that? And so they basically said, we're gonna develop a format. And what Docker really did was develop the original container format that was a YAML file, or it's actually a WAR file, or not a WAR file, but a zip file, totality, right? The
Yeah,
actual
basically a
file
GZIP file.
is a zip file, and it contains, certain textual representations in it and binaries as well. And it became a single bundling unit. I mentioned that was the second great thing about this, was that it was a simple bundling unit that if you give me a container, I don't need to know much about it. I can put it up on my hardware back here and it deploys easily. And it's because I don't care what's inside the container. I, as a hosting company, could care less what's inside your container. Everything I need to know about your container is just like on containers going down the road. If you're gonna go through a tunnel and I see a hazmat sticker on your trailer, you're not going through the Holland Tunnel, right? Because there's a sticker on the outside that shares some information about that container. And that's what we go by. So we don't care about the contents inside a container. We put labels and stuff on the outside of the containers. We make operational decisions on those. But the real beauty is I can, as a chunk or a bundle, just deploy that. Now, that's a huge benefit, and
that's what the Docker company.
that's what.
So back to your question, who is Docker? It's a company that does make software, right? And that was what they originally.
That was their
used to
original
do,
file
right?
format to bundle all that together. Now,
So what do they sell?
so what do they, so they came up, yeah.
Interesting point.
So they actually, if I recall correctly, and I don't want to go too far because I'm way out on a limb here, they sell the original thing they sold, which was the ability to do containers. But much like other smart, bright software companies, they sell other pieces of software that allow you to manage and manipulate and do stuff with containers today. Is that
Well,
correct?
I look at it this way. Linux is free, right? It's open source. We all know that. How does Red Hat make its money? Right?
Maintenance.
Right?
Support.
There's that enterprise support model, and you see that with all the big companies, right? I like open source, but it's gotta be supported, so I want my enterprise support model. So what does Docker do as a company now? They do Docker Enterprise. So they've taken their open source offering, came up with an enterprise supported offering that includes some more management capabilities on top of it, bubbled in vulnerability analysis of containers as well for security vulnerabilities, and they now resell that at an enterprise level. So that's how they're making it.
You get an 800 number. When
You
your
got it.
containers aren't working, you can call them up and say, my container's not working, and some smart, bright people at Docker will say, oh,
Yep.
change this and it'll work better, right?
That's what the company's doing. And so, and they developed ultimately a product called Swarm. And Swarm was, as is mentioned, you kind of start off with big containers, but you start driving to a world of microservices. And I won't go into why, but you do. And it increases, and I will in a second, let's say it that way. But it increases the number of containers you've got. Now, if you're at home and you're running 5 or 6 Docker containers, you don't need Kubernetes or anything else. I know that where my containers are. There's only 5 of them. I haven't lost them. I know which servers they're on. So it's very simple. I can use the Docker APIs and I can get a lot done. But when you've got 50,000 containers running from all these different departments, and it's just a problem of scale. So I need a way to look, cross-cut, and select containers out of these herds of containers. And Docker developed something called Swarm, right, to deal with containers at scale. Now that didn't fly because Google also released something called Kubernetes, which most of you have probably heard of. And Kubernetes became the dominant kind of de facto standard for that. So Docker went back as a company and said, okay, we're going to change our game plan. We now support Kubernetes as well. But that's where the companies took plan.
Does that answer your questions?
Can I ask a follow-up?
Oh, there's a third question, but what the heck? Go
No,
for it.
no,
Yeah.
second. So then is Docker the thing running on the Linux operating system that is creating these containers?
It is the operating system enforcement of the container multi-tenancy model. So yes, Docker is a host-level mechanism to say that these processes that are now running inside containers can't see each other. Now I enforce that for this building, for this host. It does not cross any host, it's just inside the host.
So when you say host, you mean?
A server, a host.
One physical box.
Yeah, it might be worthwhile.
Yeah.
No, great question, great
There's
question.
a great phrase in the industry, cattle not pets. And so what that means is that in a virtualized world or a bare metal world, you have a server. It has a name, it has a health, it's a state, you care about it. If it goes down, maybe you get email alerts or some other pager thing, you have to go attend to it. Containers, they're not pets, they're cattle. And so if my service dies or starts to feel weak, we kill it and we replace it. And it's a rather brutal process, but what it does is it sustains the overall systematic operation. And what the Docker daemon does on the Linux host, and whatever magic Microsoft does to make Hyper-V Docker compatible, what's that doing is it's providing a target to inject a new container. And in terms of Docker's future, OCI as a standard is pretty much. We've heard lots of topics. I know there's a way to do it. So once you get past your desktop in a very mild case of orchestrated containers, you're going to use something like Swarm or Mesos, or today really use Kubernetes. And what's happening in Kubernetes is up until a few versions ago, they natively supported Docker. And then the OCI standard matured, which is essentially what Docker as a standard. And now they support OCI. And anybody that wants to be a container engine creates what's called a shell. And so Jess mentioned Rocket, that's one. Docker itself, I think there's one or two other competing ones that are in play. And if you want to use it, that's great. And there are actually compelling reasons. From a security point of view, like George said, it's there to enforce it. It doesn't do the best job all by itself. And maybe an environment we want more security there.
So, actually, gentlemen, I think a path that Karen might be interested in going, whether or not she wants to go there or not. So if I was a CIO, who had read some articles on containers, and decided my company needed to go to the world of containers, obviously there's a lot of different ways I can go into containers. Docker being like sort of the IBM of containers. Right? No one ever got fired for going Docker. Whatever the story is. What would collectively, gentlemen, all three of you, what would your recommendation for somebody who's just getting into containers to do? Should they go the Docker route, which is probably like the oldest guys who've been around, but maybe they're getting Eclipse, but they do have a support network? Or should I really go like open source and save myself a chunk of cash because open source has 1,000 people working on it and everything will always be supported? I know it's on managers on Google. What would you have any recommendations for somebody who's not in containers, who decides to go into containers? Which direction? What would you think would be the best thing for them to do? There's probably three different answers here. So we'll start with Jess. Jess, what would you do if you were that? Well, recommending had the CIO's ear. Let's say that.
I think as a developer, the main thing that you want to do is create a progression. And so you want to start small and kind of build out. And Docker creates kind of an airstrip, a clear path for you to fly off of, because there's so much content on the internet about this. It's been around for years. There's examples everywhere in every language you can imagine of how to do just about every common task in software. So, just align the goal of your software with something that exists, that there's an example of online, and dissect that example. Make it an experiment and start playing with it and see what you can do. And if you start with Docker, you won't have any really large obstacles, insurmountable obstacles early on. Whereas I think if you go to the more open source route, it's going to require a lot of domain expertise depending on what you select, and probably a lot more pain up front. Now maybe the future state is better because now you can jump around and you have full domain knowledge of what's going on under the hood. But I think to get started, you really just need to get something out there and start playing with it. I know that's how I learned best. So I'd suggest Docker.
Yeah, which brings up an interesting point. So if I did that, which I think is a great way to start, so I get started playing with it, I got some Docker stuff up, I'm running, and I'm going microservice E into my number of containers and start to boom, boom, grow up and stuff like that. Is it possible to switch from Docker over to an open source one at some point in time, or it's like a tattoo? Once you got it, and you're going to be a Docker house forever.
I think these things will change over time. So the answer that we have today might be different in 3 months.
Okay.
But in general, there's opinionated choices built into Docker that I don't think will necessarily be the standard.
I get you. Okay. So could I switch from Docker to something else, or would that be painful?
It'd be work. I don't know that'd be painful, and I think the conceptual framework would carry over, but the details of what the file structure like
So
that would be different.
it's a project.
Right.
Okay.
I think given the footprint though of the number of installations of Docker, if there is a newer standard that's really being superior, I think we'll spend a sizable amount of money that there will be tools to migrate.
That's a good point. Excellent. Okay. So
And I do want to disabuse the implication of your question, which is Docker at the desktop is free. And if you're getting started, you've got some very simple choices. If you're on Windows, Windows 10 and above, use Docker for Windows. And in fact, that's awesome. It's built into Kubernetes, right? Ready to go. And it's free to use. And then you've got containers running your desktop, and you've got even a full orchestrator on your desktop. Use that. If you're a Mac, you get the same thing. If you're less than Windows 10 and you're still in the Windows space, you can still do, I think, Docker Workshop. There's Kubernetes using like Minikube. If you're in Linux, which is an awesome place to be, you can just, depending on your distros, apt-it or yum-it or whatever, get your Docker in there. You might have to add repos to make that work correctly. And then you can install Minikube and you've got orchestration as well. If you want to play at the next level of scale, you've got cloud, right? Amazon offers ECS, which is Elastic Container Service. They get Elastic Kubernetes service. You have some other weird kind of options that are unique to AWS, but GC offers, and Azure offers, and Pivotal offers, DigitalOcean offers.
Google, let's not forget
Well,
Google.
Oh, by the way, what are they called? I don't know.
Yeah. So I would think that's where you should start. Just
Okay.
go to the free download and you're good to go.
All right. So if you decide to go the container route, it sounds like it's fairly easy to start.
Well, your first question was you were a CEO. So talking to a CEO, I'm probably not going to say this, start playing with Docker at home. To answer those questions, I think CEOs look at a couple of things. They say, what applications are going to be containerized? And what infrastructure do I need rolled in the next 3 years? Because, okay, enough of my people are sold on containers, I better get started, I seem to be behind the curve. Okay. So the first question as to what you should containerize was answered really well at a DockerCon by the CEO of ADP. ADP, the
building
tech
guys.
company, right?
They
huge
do my
company.
paycheck.
And he basically said that their first approach, he likened it to an ice cream shop. And you can see the video online, but he says the first thing you try to do is you try to get the ice cream in those big containers, get them under the glass, right? So you get your things in containers. Yes, they're monolithic apps, who cares? Get them in a container, right? They're the big pails of ice cream. Now they're under the glass. At least you've accomplished that much. The next step is to start refactoring that. When you take a scoop out of that ice cream and you put it in its own container, and so you look at how you can extract services and components out of the monolith and start refactoring and busting it down. Because containers offer you the ability to scale at a greater fidelity. Now, if you have to scale a monolithic app and your I/O is not great enough, then you make replicas of it. 5 of them, 6 of them, whatever you need, right? That's a lot of large replications, right? But if I had that monolithic app split down into 6 or 7 different components, it might just be one component that needs to be scaled. See? So now I take that component and I scale it 5 or 6 times, and the rest I leave as singletons out there. And I use a lot less. As a matter of fact, I now have room left over to do that one thing 6 or 7 times rather than 5. And now I'm starting to use my hardware more efficiently.
That makes perfect sense. Well, excellent. So that's good stuff. So we've been singing the praises of containers, which is also the whole purpose of tonight. But I'm going to challenge Jason here for just a brief moment. say, Jason, look, they're containers, greatest things since sliced bread, we're all cool with that and stuff like that. But there's also virtual machines. So I got a question for you, buddy. So can you think of a situation in which it would be better to use a virtual machine instead of a container? And I'm doing this just because I want to watch George just sort of sit over there and tremble. So
Oh,
I know he
I
knows the
already
answer.
know one.
I know, but that's why I asked Jason. I want to challenge Jason, because Jason is, he's drinking the Kool-Aid when it comes to containers. So now I want to put him on the other end and go, damn, I can't think of anything that you would ever want to use a virtual machine instead of a container for. But I want to challenge you. So.
Well, I actually use virtual machines for my control plane for Kubernetes, not the least of which is path of least resistance organizationally. I think in certain cases where you want to have essentially remote desktops that are stateful, there may be a case for some sort of virtualization type scenario there. Again, you're talking about a stateful application. If something is truly stateless and without a UI, again, I'm very open to the idea that there are edge cases, and I deal with a broad spectrum of problem statements, and so I'm very mindful that if I make a definitive statement, I'm very likely to be foolish in retrospect. I would say, though, that if I think I've gotten to a place where I can't do it other than with a virtual machine or bare metal directly, I probably will ask around and see what I missed. But I'm still open to the idea that, yeah, there's some edge case that requires it. It is a smell, though. It is something that's going to give me pause, and like, I think I can only get it here. A lot of times, so we talk about VMware, Microsoft has a Hyper-V, Oracle has their own solution this is the way. There are very interesting things you can do with virtual machines. You can, in fact, we do name the fittings and things like that. But most times I see people not realizing that they're not actually using the benefits that are there. It's ability to move your virtual machine around to allow for hardware failures, even with the latency compared to a container spinning up. So a lot of the times, I don't think we actually took as much advantage, at least in pockets, of what virtual machines are doing in the first place. But having said that, I still, like I said, you've got an edge case, I believe you. I still think it's smell.
You'll know at the end.
Gotcha. Yeah, I'd like to point out that both Jess and Jason don't have a great deal of gray hair. Okay? And because of that, I think they see the world in terms of new code. I can write that. That's not a problem. Now, I'd like to point out George does actually have some gray hair. So I'm thinking, if I was George, he might point out the fact that I think if you're in a situation where you have multiple operating
There you go.
systems, if all your old shit's running on different versions of, we're a big Windows 7 house. Oh my God, really? Still? But I think if you have multiple operating systems, then a virtual machine still becomes a arcade.
What we used to do on developer laptops, right? When VirtualBox came out, sure,
Yeah.
a lot of people in the room did, right? We started loading virtual machines, and it wasn't long before you said, well, can I, if I'm running Windows as my host operating system, can I run a Linux virtual machine and get into Linux that way? Can I get the Mac OS there on my Windows box as well? And what about Android? Can I get an Android virtual machine running so I can get to my same phone apps on my desktop? You can do all that with virtual machines, right? So when I do distributed application development, if I have to cross operating systems, a virtual machine is an excellent choice now to keep it right there on the desktop, right, on my laptop.
Same
Yeah, cross the
physical
operating-
box, right?
Exactly. Now I can go and I can have 4 or 5 different hosts that then I can deploy out to real servers or hosts later on. But I've got a development environment.
There is a wonderful expression, though. You don't get bonus points for developing a different operating system you deploy. So,
That is true.
One of the interesting things too is that people are now virtualizing old mainframes, like COBOL mainframes, and they're putting them into AWS and offering them as a managed service. And I would imagine that that'd be a pretty nasty job to put that in containers. So,
But there's a truckload of COBOL out there,
Oh,
right?
sure.
So, all right, so we're back to Jess, who's our developer guy. So, Jess, I challenge you, sir. Just give me just like ballparks here. I have a single server. You can get any server you want. I don't care. You can Dell server, some server, whatever. How many containers can I run on a single server?
oh my goodness.
Just give me.
I go one.
Expand my brain. Is it 1? Is it 10? Is it 100? What am I looking at?
There's a lot of variables there.
And granted, you can size the variables however you want to
Okay.
answer the question.
So let's say that you have some sort of a microservice, some sort of server-side application, and it's servicing a large volume of inbound requests. And like we mentioned earlier, one of the nice things about containers is that just the part that needs more, you can scale that container out. Well, at my job, we have a system that takes several 100,000 requests a second, and it takes 9 containers to do that workload on a box. Now this box is an EC2, so it's Amazon's VM hardware, and I want to say it's got like 32 gigs of RAM and 16 virtualized CPU cores, so it's a beefy machine. But we did a load test, and we were able to run over 100 copies of that container, and we were nowhere near full on the box.
Oh, wow, okay, all right, so you had expansion room. If
Yes.
you're only running normally, if you had to blow it up, you could do it, you wouldn't have to get it in the box.
Right, that particular use case can scale well. Now, I think if you're doing something very intensive like, digital signal processing, where you're doing like constant Fourier transforms, a lot of intensive math, that would be a bit more top-heavy. That container would be more expensive. So if you had to scale a more expensive container, you obviously fit a lot less.
Of course. All right. So it depends what the container's doing. I guess.
Absolutely.
But still 100 containers on a single box.
Yeah.
So a single server potentially has 100 containers on it. I mean, we could almost put that as a stick in the ground without too much problem. And once again, you're exactly correct. It depends on what it's doing. But just in the normal sort of business, I'm doing email processing, or I'm doing HR stuff, or it's stuff that is not 48 transforms. I'm sure as imagination. It seems like I could start looking at servers and go, I have to put 100 there, 100 there, or maybe I could put 200 or 500, on a single server potentially, right?
Sure.
So I need to be thinking 3 digits perhaps as far as the number of containers that can go on a physical server. Once again, just rule of thumb, and obviously different in every case. No question about that one. Okay. All right.
But you don't need a strong laptop, right? Because then you can run something on your laptop, no problem. You can probably run 5 or 6 and not have any issues.
Gotcha, and be mindful of concurrency too.
We have a
This may
question
have
in
a
the
lot
back.
of variability to it, but what's the lifetime of a container?
So that's a really good question. With traditional software that's running natively on the server, restarting it can be a big problem, especially if you don't have downtime. But in these distributed environments, especially in the cloud, what you can do is what we call looping deployment. So you can say, my app's out there and it's running, and that's the blue copy. And let's say that all my tests pass, I've got a new release that I want to put out there, that's the green copy. So then I can use, the networking, the DNS, to route traffic to the new one. And once I've routed all the traffic over and it looks good, I can just kill the old one. And some folks take that as far as to say, that's great for upgrading, but I just want to make sure it doesn't run too long in case there's a memory leak or there's some kind of security threat that's posed by that. So they'll actually have automated software that goes and says, this is older than 6 hours, just squash it. So another one pops up in its place. So it's really an interesting concept, right? It's like, what's the shortest password you can get away with as a function of how quickly you change it,
I assume there's also a cost for every container I create. So managing that, I assume there's always a cost function you're trying to drive down. So
Well, I would say, if you have a very large application with like 30 copies, and you want to do an update, now you need 30 more, or you need at least 10 more and gradually start routing over traffic. So there's that moment where you have 120%, 140% capacity provision. But for most applications, the act of just saying you want that container, it seems to be a pretty lightweight, very snappy operation. I mean, it takes like 10 seconds.
Okay.
So I don't know how intense it could be.
Okay.
So there's a concept I use in the industry. And there are some good examples of that. Most of us understand the software development life cycle. We have to build software. We have to test software, right? And then we put it in production. But how does that building and testing happen? Well, that's software too, by the way. And so if I containerize that software, I call that container a builder, then I can use that container to build new containers, right? And how long does that container last, that builder container? For the life of the build. Then it goes bye-bye. So I can create various containers, and as a matter of fact, OpenShift does this. They have several containers that will identify the source code, and based on identifying the type of source code, it will select you a builder, and it will build you a Node.js or PHP or whatever, and out comes your container on the other end. And that's a short lived. Now you can also think that testing is kind of in the same boat. Like if you're following test-driven development, then your tests should be 3 to 4 times the code base of your functional code, because you're doing so much testing, right? Well, testing is like war, right? The only good part of war is its end. Abraham Lincoln said the only good part of testing is when it's over with, right? And you don't want it to take days or weeks. We're not in those modes anymore. So I need to quickly parallelize all the testing I can, scale it out, ramp it up, get it done, and approve, thank you. So how do we solve it? We use ephemeral containers to run those tests, and then we bring them down. So ephemeral containers are these short-lived containers that are put in for single-purpose duty, as it were, and then pulled back out of when they've completed the task.
And to add to that too, in terms of the lifespan, if you are gonna test your service, right, your application, if you deploy it and it has an uptime of 30 days, 100 days, whatever, how much testing do you have to do to test its life cycle? 30 days, 100 days, whatever. If your application is going to be killed within 6 hours, you can't test its full life cycle within 6 hours. I think maybe faster if you're clever. And you still may have to worry about emergent properties, about the longevity overall. It doesn't do it for free, but the idea is I don't have to worry about how the system behaves 3 months down the road if it's going to die in 6 hours. And so there's a huge advantage of that.
Just remember, when we're trying to think of the scale and what the containers cost us, that the original goal was it shouldn't cost you anything more than processing, right? We started out doing Linux-based processing, right? And we got virtual machines on the hypervisor, and that was taking away. So we were looking to get back to the grassroots, where it took as long as it did in bare metal. Containers were the thinnest type of multi-tenancy security model to maintain that per process isolation without affecting processing efficiency. So it's more about what you can get on the hose. The bare metal hose is bigger, better comparison.
Perfect. You have a question?
Yes. In order to make it more, I would say, practical, the use of the containers, I have a production power supply for the U.S. Army, say, that has about 120 specifications that need to be tested on the power supply, an automatic test station as it flows down the production line. All right? Can I say that I can use a container to generate the individual test process for individual 120 applications? So I would have 120 containers to test each one of these applications. Can I say that, or is it only a single process to do the whole thing?
Well, with all testing, there's always an issue of do you have to do them in order, or can you do them parallel, right? Because a test, when you run a test, a lot of times you'll affect the state of the system under test by the test. So your next test, so now if you rearrange the order of your tests, things start failing, right? Because something switched earlier.
It has to be
so you have to eliminate side effects. But if you eliminate side effects, then yes, the answer is you should be able to parallelize those things coming from a known starting point, a known state, and run all those tests in parallel and resolve in known states.
And actually, George mentioned earlier as well, your tests are code. You need to make sure your tests are correct, what test to test. Also, as you deploy conversions, how are you doing that effectively? How are you going to have confidence in the state of the mechanism that tests whatever your widget is, your power supply in this case? So I would look at it as a strategy of compliance, ensuring what am I actually using to test it? How do I prove that? And when I get improvements to it, how do I roll it out quickly and with confidence? And one thing, Jim, we were talking about beforehand, before the meeting started, and maybe more interesting to this group, containers aren't bound just in racks and servers. And there's a growing population that are using them on ARM devices like the Raspberry Pi and other groups. And I talked to others, there are different strategies of actually deploying an embedded application as a container. And there's some really cool side effects to that. Amazon recently released a whole class of EC2 virtual machines, containers, that are ARM-based. And so there may be a level of abstracted testing that you can provide on your native code, assuming it's compatible enough with their ARM architecture that you're doing, caveats for everything, right? But this idea that you can actually start testing your application without using emulators, without having to put in your hardware, because one of my roles is CI/CD, continuous integration, continuous deployment, delivery. The goal of that is to fail as quickly as possible. And what can you do to get the fastest one? Putting your application into hardware presents very unique challenges. If I can test that and look at localized changes or even regression type testing and fail before I even think about getting it into a mechanical test fixture, I've saved a ton of time, because the round trip back to my developer while it's still in their cognitive, their working RAM as it were, is way better. So just as an idea of just don't think compute. Where do I have compute? And is it possible and potentially even advantageous to throw that layer in there
And I think for electrical engineers, the key concept of containers would be an integrated circuit. For years, software development was jealous, right? We would love to have an integrated circuit, right? We could put on the board, and it operates the same way every time, it's the same quality specs, because it has these 5, 6 prongs. This interface is standard, and I can use it a bazillion times with known quality and known durability. That's what we want in software components, is everything I just described is the software I see. So how do you achieve that? Well, the problem in software is one of transitive dependency. When you really look at it, as systems grow, we have libraries of software that gets reused. Well, how does that library get into code? Well, it's compiled in, it's linked in there, right? Okay, so but what if I make a change to that code? Well, the change to that code made a change to that library. That library was included in that library. That library and that library were included in these 8 applications. So you end up having to rebuild all this, right? That's transitive dependency. A depends on B depends on C, therefore A depends on C, right? So I have to rebuild and track this tree. The beauty of microservices is to remove transitive dependency that is formed at compile time, put it into a runtime dependency, a dynamic runtime dependency. Now, how do you do that? Well, I put a service out there on an IP address. If you want to talk to it, go talk to that IP address or talk RESTfully to it, right? I don't care. But if I need to update it now, so rather than sharing that library and linking in statically, that piece of functionality is now out there as a small service, right? And if I need to get to it, I call over the wire to get it. And if it's on my same host, the wire is the local host virtual network, and so it's equally as fast as any other invocation, right? But it's an effective abstraction model of getting rid of transitive dependency, right? That's the real beauty of microservices. I can change one thing, I can redeploy one thing, and all dependencies are met, because dependencies are all moved to runtime.
Excellent, very good. Now, I had teased the audience that there was something called Kubernetes, and you guys have mentioned it occasionally, just in touch. You haven't gone into anything down, just teasing once again. So now we're going to look at Jess, and we're going to say, yo, Jess, I've heard about this thing called Kubernetes. What the heck, outside of being a goof-ass name, what's up with that? I mean, we just call it what it is, whatever. At any rate, could you tell us what it is and why the heck I would care?
I'll certainly try and hopefully these guys can help me. I haven't been doing this for very long, but this has got to be the coolest thing I've ever seen in technology in my entire life. So this container concept can be distributed into a cluster, right? So we had mentioned earlier things about, you can run a lot of containers and you can have thousands or tens of thousands or hundreds of thousands running. So Kubernetes was actually invented at Google. It was based off a model for a different system that they built, and open source kind of took it, ran with it, and did some interesting stuff. But the basic idea is you take this container paradigm and you describe your workload using these files, these YAML files, of the state that you want your cluster to be in. And so you say, I want this container to have 5 copies spread around all of the different compute nodes in my cluster, the servers that are running my containers. And the scheduler in Kubernetes will figure out which places within the cluster make the most sense to put it, where it can get the specs that it needs and the RAM that it needs. And if one of them dies, it'll notice that it died and it'll pop up another one. And you can do all kinds of monitoring on top of this. And people keep extending it to do more and more for you. So at the end of the day, it's really an impressive set of tooling that enables this platform around containers, where you can run all of your workloads and have reliability and guarantees about how they behave. And you can describe things that you want them to do or states you want them to be in, and it helps you achieve those states.
Okay, and so you guys, I think you actually brought up the point. You have at your work, you have an application that is, let's say, broken into a bunch of different containers, and one of the containers apparently handles talk to the outside world, and it's got like 100,000 things coming in every hour or whatever. Every second, 100,000. So obviously, that thing, depending on what's going on, it could start to grow. You can make multiple versions of it. So you started out, let's say, with like 5 containers. Okay, this thing is getting 100,000 things a second. Say it goes up to 200,000 or half a million things a second. Oh my God, let's make some more containers. All of a sudden you got like 50 or even 100 containers just doing that one thing, which is great because that's exactly what containers are for. Yeah, you have this. but all of a sudden, your management issue went from, hey, I'm trying to keep track of 5 containers, make sure everything's running and restarting, things go weird, to now you've got, potentially 500 containers. Oh, shit, I gotta come into work early and stay late. This sucks. But I guess in that situation, all of a sudden Kubernetes becomes very important.
Yeah,
Right?
so some of the things that have been mentioned earlier about immutability become very important, because you can look at a container, know the application running in it, know that it's been tested, and know the exact life cycle of behavior with stimulus from the outside world, whether that comes in over a network or a file system or a database. It has predictable behavior. And so whether I have 50 copies of an app or 50,000, I should expect the same semantics of behavior. And the other thing too is there's a lot of plumbing you can put around this tooling, this platform. And that will say things like, oh, when my CPU utilization across all these containers trips 65% of the maximum I've allocated, I want you to double it, put another 5 of these containers out there for me automatically.
Oh, wow. Okay. So
Or I want you to tell me on the chat app that I use at work.
Almost scripting at that point in time, right?
Yeah,
Okay.
well, because what happens is you have these tiny little controllers that are running in the cluster. Many incredible products that are open source have already been written you can use to do these things, and some of them are baked right into the platform. So if you just Google, how do I make this thing scale? Somebody's already written a little file, and I mean, sometimes it's 6 lines of YAML in a little file, and you have infinite scaling. That's incredible.
Excellent. Okay, so that sounds very good. So Jason, now we go to you, buddy. So if I'm starting to play around with containers and doing stuff, am I sticking Kubernetes in from day one, or is there a trip point? When I hit this point, all of a sudden Kubernetes becomes part of my life.
So for Kubernetes, and also, if you see, it's also called K8s, Kates.
Why is it called that?
Because it begins with the letter K, there are
Yeah.
8 more letters, and then it ends with the letter S.
Dear God, yeah, okay, that makes perfect sense. Sorry, yeah, okay.
Yeah,
all right,
okay.
all right.
So, and it basically is a Greek word or
Virtualization.
Yeah,
whatever.
there's a Greek word, it means helmsman, the person driving the ship. And you can blame all this in Docker because they use the way on the container.
There we go. Okay, that works.
And in fact, there are things called helm charts and tiller and all for helm. Actually, as a real quick thing, if you, and I say this all seriousness, there's a YouTube video, but there's a book called The Children's Illustrated Guide to Kubernetes. It's followed up by its sequel, 50 Goes to the Zoo. And so the guys that created Kubernetes created they left Google, they created a company called Heptio. Heptio created something called the Cloud Native Computing Foundation. This other group created Children's Illustrated Guide to Kubernetes, and they donated to CNCF. So it's this open source book. It's actually fun to watch. There's YouTube videos for it. I read it to my kids. 50 Go to the Zoo could have been a horror story, but they walked away. Remember, they're cattle, not pets. We kill them when they're weak, but they don't cover that in the children's version. I think realistically, one needs to understand the core of the containers, and probably worthwhile to handwrite some Docker files into the containers, the images themselves. How soon you enter into the wonderful world of orchestration, scheduling, all the rest, really depends on your business need. I mean, if you're curious, it depends how you learn too. I usually need a reason to do something, and once I've got that, I learn quite a bit, and I'll do it. I think you mentioned earlier, if you've got 5 or 6 containers, use Swarm, I guess. Well, the reason I say that is Kubernetes, if you're going to run it in any practical sense, with any resiliency, you either can run it one machine and you've got it great. After that, your explosion of core capacity expands. We run bare minimum 3 controllers or 3 SEDs. That's like, so essentially 6 instances of machines right there, and that's before we have the first bit of compute that actually lets you run your things. So there is a certain amount of threshold of cost that you're going to incur just to get started. But the moment you've got that, you know how to create a scalable platform. But it's a gateway drug, because you do CNCF.io and you realize there's all these open source things that start solving all your problems. One thing that Docker offers that I think is only slow, I think Notary is the open source version, is the ability to digitally sign your container. And the reason you do that is just pure awesomeness, because I don't want to talk to people in my pipeline. I want to go as quickly as possible. I don't want to have meetings where we sit around debating the merits of releasing something. So if I have to have approval for somebody, how do I do that? Well, one way is they can just sign the document. In this case, it's an image. And I can actually use gating and not let containers be advanced through my pipeline unless they're digitally signed by groups that I care about. So that's pretty darn neat. I have never had the bandwidth to actually explore that beyond saying that's pretty big.
Let's talk about this after.
Yeah, fair enough. So they're great things. But if you look through a lot of the problems Jess had mentioned, if you do some quick searching, you're going to find that people have addressed it. You also find that there's a great GitHub repo now that's aggregating all the Kubernetes failures. Okay. And there's interesting ways in which complex systems can die. looks really great. In practice, it happens. So you want to know why that is and how you can make it not happen to your system. One thing that's kind of worth mentioning is, we talk about containers. You go to Kubernetes, containers are no longer your fundamental unit. Instead, pods are. And the reason they do that is, as I mentioned with the 12-factor application, I want my application to be the least amount possible. And so it's writing out the standard error and the standard out. Well, I can do what they call I can do a sidecar. It's another container that's listening to its standard out, its standard error, and then marshalling the data somewhere I care about. I can actually use it as sort of an ambassador thing and go, you know what? I need to bring in data in a different format into this guy. Well, I don't want to change my application from data formatter, but I know it's coupled tightly to my application. I can throw another container whose job is to potentially change the data or look at a foreign repo of some sort and bring the data in locally. So what can I do to protect my core capability so that it's as simple as possible, so it's predictable as possible, and so I still get my horizontal scaling as well. And so there's a lot of goodness that comes from that, but I think you need a reason.
And that might be the key there. All right, we're approaching the tail end of tonight's presentation because the cleanup crew has to come in from the room. So let me just do a real quick circle here. Do you have any specific questions for our panelists or anything that they've touched on that triggered something that you didn't have a chance to ask a question?
I still want to know how I keep a landlord out of my apartment.
You put a bunch of containers in front of the door and they can't open the door.
Just lock the door and you just throw your apartment away.
That's it. That's right. New apartment.
Your apartment is
I
cattle.
had a question about the, understand a lot of this is software development, so, like, I work for a company that we buy a lot of software.
Okay.
So, for operation, right, so, it's very, like, developmental intensive, because this company that we deal with, they're always, trying to innovate and trying to be the first in the market, push out this new product. So, and we're like, and our management is like, yes, security. Like, where I come in is this cybersecurity part, because, how do we ensure that, we don't shoot ourselves in the foot by getting a lot of, containers from these companies?
Well,
Oh, so quick, just real quick, I apologize for my edification. Can you buy containers from a company? Can you buy containers?
It's
Like
just
plug
an
it
app.
into your containers? I mean, or do you have to buy software and then stick it in?
you can buy software from any company on the planet, and they could have containerized that
So
software.
it's entirely, so you could possibly buy containerized software
Yes.
today?
Yes.
That is, okay, thank you, I appreciate it, please continue.
Now, so first off, I'm an ex-CTO of a firewall company, so if you wanna talk after this, we can talk about cybersecurity and the issues you're facing. And I mentioned that one of the compelling, like I love microservices, I'm deep into the event-driven architecture of microservices, so I love that part. But I mentioned there were two key things about containers that most management gets traction on. That was the density and the bundling. Now, the bundling is something that you hit right away. And I hit it at Duke Energy when software vendors would come and say, I've got your latest release, and we have to install it on premise. And that was, let's get 10 people from Duke Energy on a Skype session, watching somebody at Duke Energy with the authority to actually perform an install, and the 4 vendors on the phone to find out that some part of the install didn't work, and they were looking through manuals to find the missing configuration parameter, while 20 people are sitting on a phone staring at a shared common screen. This would go on for 3 days. I mean, it was just the most bizarre ways you could imagine, right? Because you didn't have an automated install and you didn't have it ironed out. Containers do away with all, right? If you got it working at the vendor place, then you got a container, you can containerize it, and you can give it to me, and it's guaranteed to work in that place, right? Because all dependencies are inside the container. That's the idea of the encapsulation. So if my vendor has it working at his site, and he snapshots me a Docker container through a couple of different methods, he'll create me a Docker container. If I get that container, I should be able just to throw it down and it should work the same as it works there. That's the real beauty. See, that was the impedance mismatch we kept having with the development life cycle, was we get stuff working in development, we'd stick it over in ops, and it was like, well, that doesn't work. And that was your slide, it doesn't work, because of all these dependencies that were linked. All dependencies go inside the container, right, in Containerville. So there aren't changes in those dependencies.
Now,
So-
just from my application, just real quick, if I have a container that's doing all sorts of fabulous stuff inside the container, it's working beautifully, I guess containers still break if you muck the API. Is that a correct statement? I mean, inside the container, everything's perfect. That code's running. But if you play games with the APIs, you can still have mismatches. Is that
Well, containers are nothing more than software that supports APIs,
Right.
right? So how do I get to a container? Well, I get to the container through the API. So yes, if I could, mount craft packets to your API or something, I could perhaps spoil your container,
Okay.
right?
The traditional problem has not actually gone away with the
No, but one of the solutions to that is what Kubernetes had. Remember I said earlier, Docker was an inside the host mechanism, right? It was a Linux kind of mechanism built on top. But it didn't solve the problem. Like I can't tell you the last time I built an application that existed on one host, right? I constantly write distributed applications now. So what I need is a way to specify my application, my distributed application, and have it laid down, right? Both in firewall policy, enforcement through the firewalls of what can go through, plus where the different pieces of processing are and how they're allowed to talk to each other. I need to specify that in one way, and we call those pod specs in Kubernetes. That I can basically say, this is not just about the container. This is about 6 containers I have, that 2 of them are going to be over here, and 2 of them are going to be over there. These guys are going to talk to these guys over an IP address, over this port. I'm going to define the protocol, right? You define all that out. Now with that in hand, I can literally lay that down in an instant. Kubernetes can say, I got it. I got your deployment plan. Let me instantiate that for you.
Very good.
The same way, let me just segue here. The same way that we used to do memory management. Remember the old days of C where we malloc and alloc and freeze, right?
Yes.
And then we all agreed garbage collection was better. That's kind of what Kubernetes starts to give you. Because I don't care about where it's deployed anymore. That's not a decision for humans. That's a decision for machines to optimize. If 2 containers talk a lot to each other, they shouldn't be on separate servers. They should be deployed on the same server. And we can figure that out and put it.
So I was going to say, independently of the container switch, you're talking about API mismatch. That's what semantic versioning with functional testing is going to do.
Right.
The idea is.
You should catch it in your test.
Right, well, but the semantic versioning should be tested to make sure it actually truly is a contract. That is to say, I've got an API I publish, based on the version I know if it's a minor change, I'm adding capability, or I've broken it. And so whether you're using containers or not, you need a system imaging chaos. This is a great way to do it. That's another level of enforcement. And from the security, there are several companies, the big ones right now, Octosec and Twistlock. So from a security, you want to look at the definition of the Docker file and see its pedigree. What is it bringing in with it? Particularly if it's using a public image, you may be Bitcoin mining for somebody you didn't mean to. Once you've created your Docker image from your Docker file, you're going to put it into some sort of registry repo. You want to scan that. And it's not enough to scan it the first time you put it in there because the definitions of your security profile are changing. You want to scan it over time. And then once you deploy it, there's 2 different modes. I want to look at it and say, okay, is this behaving like a normal application or system? That's one. And then if it's not, I decide how heavy-handed is my governance. Am I sending a warning out or am I just killing it? And so the security is in depth. It doesn't change the fact you still have to look at the security of the artifact that's contained within the container. But again, if you can protect your immutable, you got immutable stuff that can't be changed, you throw them away anyways. Now I'm focusing all my security on my intake. Where am I storing my container images? And are they clean?
I'm laughing a little bit here because as Jason's going through, it's a valid point. If you've got this many containers and you have a security issue, the question is what the hell's in these containers and what does it do and stuff like that. I would argue that is exactly the same problem that if you're running the Port of Tampa, you've got the same damn problem, right? I've got these damn containers all over those. What the hell's in them? And arguably, the software guys probably should go talk to the port guys. Say, how the hell do you stay on top of what
You don't need Geiger counters.
There's got to be a little, there's got to be a software equivalent of Geiger counters that says, hey, this is look at the date on this damn thing. This got dropped off yesterday. It never came off a ship. Somebody's trying to slide it into the thing. Anyway, all right, sir. You didn't actually ask any questions, which is perfectly okay. But I want to double check, sir. Was there anything that we discussed that triggered a question here? And you went, oh, wait, I have a question.
No, actually, hardware guys.
Which is fine, because we talked about circuits, right? We talked about, so just a little. Sir, we covered just truckloads of stuff tonight. So is there anything that was not clear that we could touch on? Is there an open question in your mind? Just software containers and Docker?
No, it was very entertaining. I appreciate all this time.
Kubernetes. All right. So you're good, sir.
Sure.
You're my last one, sir. We've covered this much. Is there any part of this that's like a little, what the heck were they talking about?
Nothing I can think of.
Okay, you have to go home and then you'll think of it and you're like, oh,
Well,
wait.
I went through this once before, ahead of time, when I got the email.
There you go. So you studied.
I actually did,
You'll do better on the quiz than the rest of these people because I don't
Did
get
I
those.
study? I called someone and got additional input. so-
Excellent. Herman, man, you've asked every single question that's come in
Yeah,
here.
I'm sorry. I was a software engineer for many years, so I have questions in there. But in your process to doing this Kubernetes here, is there a specific preferred language or operating system that you would run?
We
this
have our own
Kubernetes?
preferences, I'm sure.
I'm sure you
Not
do.
not for containers. You can containerize. It's any Linux process, they're for any language.
That's what I was thinking, looking at. Because it seems like Linux
But
is
you'll,
the one.
you'll see some Golang fans on the panel.
It is worth mentioning though that Microsoft, while the underlying mechanism is different because they don't have a Linux kernel, they are compatible with the API. Subsequent versions of Windows are Kubernetes compliant. I've done some work in orchestrating Windows services. We wound up doing some cheats to get our containers to work correctly because the Kubernetes integration wasn't so great at the time, but it's certainly possible. So you can run, it's not Linux only. I don't know why you'd use Mac, but it's Linux and Windows.
That's actually really impressive. That's most of the time.
And ARM is starting to make a little more headway. Everybody talks about the year of ARM, that someday our data centers.
When you say ARM, you mean the chip guys?
I
As
mean
opposed to
the
chips?
people that are making these processors are starting to make motherboards that have like 64 or 128 cores. They're going nuts.
Wow.
And the cost of those are a lot less, substantially less.
There's a
Because the ARM architecture is ARM puts out an architecture, they don't build it. Then other people go and build it, right? And so there's economies of scale involved here to get the compute costs down. So that one day you can have the power of a data center in your bedroom closet, right? Not just with the electrical output of 1/10 of what we're seeing today. I mean, it's just massive where we're going with the ARM. So I'm waiting for the year that it's going to be the year of ARM in the data
I
center.
will have all the Bitcoins.
Never get out of this.
Actually, so today with Amazon, you can do RBC2s, and I know of at least one company, 6676.com, you can buy 100 core ARM racks. 1U, 100 cores, sub $10,000.
Hi, Dan.
My name is John Gasser of the entire Nielsen data center.
Pretty much.
On call 24/7.
Sadly, there is a downside to that. Well,
Never
fantastic.
leave them down again.
I'd like to thank everybody. I'm sorry, Jim, was there a quick question there?
Our solicitation.
Oh, yes. 1 minute. You get to do that in 1 minute.
Okay.
You get to, and thank you for reminding me. It's fun. So we appreciate our panel members coming and presenting to us tonight. Instead of giving them silly little plaques or little things like that, what we like to do is offer them chocolate. So I would ask you to make
You
a
are so
selection, sir.
smart.
So we have dark chocolate.
Which is dark? Which one's the dark?
These are really good. Does that seem
No.
How about that? All right.
That's special.
Sir, you get to choose whatever makes you
I
happy.
may have to wait somewhere.
That's fine. Now, what we promise you, and this is our guarantee to you, is that we will never tell anybody that we just gave you a gigantic bar of chocolate, okay? So you actually don't have to share, okay? Nobody's ever gonna come and go, hey, where'd that bar of chocolate go? Nobody's gonna know, because they'll never know, okay? And if you don't like chocolate, that's okay too, because you can always give it to somebody and everybody else likes chocolate. So you got like a double bang. Ladies and gentlemen, did we enjoy our presentation tonight? A round of applause. Gentlemen, thank you so much for taking time out of your evening. Everyone, thank you so much for showing up. I greatly appreciate it. Tonight's show has officially come to an end. Thank you very, very much. The Hamilton people should still be engaged in their play, so there should be no problems getting out of here. Okay?
And I have